Hello PLP Geometry. Welcome to video 6 in Unit 4. So again, we are still cruising along here with our right triangles and our similarity. So this is Unit 4. So we are doing similarity and right triangles. And again, we're going to continue our discussion with the right triangles, talking in this video, video number 6, about special right triangles. Special right triangles. All right, let's put a little recap, right? So if you remember last video we learned this thing called the Pythagorean theorem. Pythagorean theorem. Pyth, T-H-M. So with the Pythagorean theorem, right, if we had a right triangle, so Pythagorean theorem, we have a right triangle with two sides. That means with two sides. We could use that information to find the third side. Okay. Well, today we're going to talk about special right triangles. And with special right triangles, so we are going to have a right triangle. They're going to have either a 30-degree angle, a 45-degree angle, or a 60-degree angle, and one side. One side, not sides, one side. And given this information, right, we can then find the other two sides. Other two sides. Again, this is what today is all about. Special right triangles. You have a right triangle with either a 30-degree, a 45-degree, or a 60-degree angle, and one side given, we can find the lengths of the other two sides. Okay, so there are two of them. So let's talk about the first one. All right, let's use yellow. It's been a while. There we go. Okay, so the first one is called a 45, 90 triangle. So the 45, 45, 90 triangle. Now, when we think about the 45, 45, 90, that's a 90 triangle, right? It actually comes from a square. So I'll put a little asterisk, square. So what happens is if I draw a square, we know two things about the square, right? First of all the sides are the same. Secondly, all the corner angles are right angles. Okay. Now, if I take that square and I draw a diagonal through it, okay, what you create is you create an isosceles, that's an O, isosceles right triangle. And I'm going to draw it right over here. So I'm going to draw the one on the bottom right. So it looks like this. Kind of wonky, sorry. Wait, I don't know what that was. So it's an isosceles right triangle because I know that these two sides are the same, right? And has a right angle. Well, if those two sides are the same, then these two angles must be the same. And again, long story short, the three angles add up to 180. This is 90, so 180 minus 90 is 90. 90 divided by 2 is 45. These two angles must both be 45 degrees. And lo and behold, your 45, 45, 90 triangle. Okay? Now, this is still a right triangle, so we have a leg, and we have a hypotenuse. Here is what the relationship is between the three sides. This is the important part. So we know our two legs will be the congruent, right? Because of the isosceles. It's an isosceles triangle, they're the congruent sides. So we're going to label the legs S and S. In a 45, 45, 90 triangle, if the legs are both S, then the hypotenuse is S square root of 2. It's a known fact. So for a 45, 45, 90 triangle, your three sides are S, S, and S square root of 2. Always and forever. Okay? So what this means is, and again, we'll do some examples. If I am given the leg, so given the leg, All right, if you're given the leg, then the hypotenuse equals the leg times the square root of 2. All right. Now, if you're given the hypotenuse, then the leg equals the hypotenuse divided by the square root of 2. These are the two situations you'll see when dealing with a 45, 45, 90 triangle. And again, there's no Pythagorean theorem. It's just kind of like, unfortunately, it's a memorization, right? But it is what it is. 45, 45, 90 triangle comes from a square. All right, so let's do an example or two, okay, of these. So again, just quick, right? Nothing too strenuous here. So let me give you a right triangle. And I tell you that this angle is 45. And I tell you that this side is 6. And I'm going to find this side x and this side y. Okay, so first and foremost, notice that this is a 45. If that's 45, this is 45. This is a 45, 45, 90 triangle. Recognize that. So your three sides are legs S and S. Hypotenuse is S squared root of 2. Now, what are you given? In this picture, you're given a leg. You're given that S equals 6. That's money in the bank, right? Because it's pretty simple from there. The other leg is also S. So X is also going to be 6, again, because it's the other leg. And then the hypotenuse Y is going to be that leg, 6 times the square root of 2. Done so. And that's the problem. So again, in my opinion, Pythagorean theorem takes a little bit longer, right? These are quicker problems, all right? That's the point. Okay? All right, another example here. All right, so say I give you a right triangle. And I say this is 45 degrees, and I say that this is 6 square root of 2. And I want you to find x and y. Okay, so again, if this is 90 and that's 45, this is going to be 45. We have a 45, 45, 90 triangle. Immediately, my two legs are S and S, and my hypotenuse is S squared root of 2. Now, in this problem, they gave you the hypotenuse. They gave you that S squared root of 2 is equal to 6 squared root of 2. So we are in charge of finding what S is, and to find what S is, we're going to divide both sides by the square root of 2. They will cancel on both sides, and now I know that S is 6. Beautiful. And now that I know that S is 6, I know that X is equal to 6 because it's a leg. And I also know that Y equals 6 because it's also the other leg, and they're congruent in a 45, 45, 90 triangle. Okay, let's talk about the second special right triangle we have here. Okay, this second one is called a 30, 60, 90 triangle. Now, the 30, 60, 90 triangle originates from an equilateral triangle. Equilateral triangle. So if we recall what an equilateral triangle looks like, it is a triangle where all three sides are the same and all three angles are the same, meaning that all three angles are 60 degrees. Now, here's what we will do, right? We will draw an angle bisector straight down. Bisects this 60-degree angle to create a 30-degree and a 30-degree. Bisects this bottom side, and it creates a right triangle. And lo and behold, we have a right triangle. The one on the left and the one on the right. Let's use the one on the left. Okay. Now, if you look at this picture here, right, we have a 60-degree angle here, 30 up here, and a right angle. Now, if I label the original side 2S, Okay? This bottom side is half of that, which is S. And then the other side is S square root of 3. These are the three labels for a 30, 60, 90. We call the S the short leg. S. We call the S square root of 3 the long leg, S square root of 3. And of course, the 2S is the hypotenuse. So in a 30, 60, 90 triangle, your three sides are S, 2S. Let's go S. Yeah, I go S, 2S, and S square root of 3. Okay, now, if you're given the short side, money in the bank, right? If you're given S, so if you're given the short leg, then you know the hypotenuse equals the short leg times 2, and the long leg equals the short leg times the square root of 3. Money in the bank, right? If you're given the hypotenuse, then to find the short leg, you have to take the hypotenuse and divide it by 2, and then you would just find the long leg by taking the short leg and multiply by the square root of 3. And if you're given the long leg, to find the short leg, you take the long leg and divide it by the square root of 3. Let me make that better. Divide it by the square root of 3. And then to find the hypotenuse, you would take the short leg and multiply by 2. So these are the three situations you might see when it comes to solving a 30, 60, 90 triangle. Again, notice none of the sides are the same. So unfortunately, because the three angles are different, the three sides are also different. Okay, so let's do two examples involving a 30, 60, 90 triangle. All right, the first example here. Okay, I have a picture. Okay, right triangle, 60-degree angle, and I say that that is 4. Let's call this X and this Y. Find me X and Y. Well, this is going to be a 30, 60, 90 triangle because that's 90, that's 60, so this must be 30. In a 30, 60, 90 triangle, we have the short leg is S, the hypotenuse is 2S, and the long leg is S square root of 3. Again, a lot of students label the hypotenuse and the long leg. Try not to do that. So in this problem, they give us the short leg. The short leg is 4, money in the bank. To find X, the long leg, just take the short leg and multiply by the square root of 3. That's the long leg. And to find Y, the hypotenuse, let's take the short leg and times it by 2. And that's 8. And that's the hypotenuse. And you're done. Okay, and now a little bit more difficult one, right? One that's not where you're given the short leg. So next example, so let's see this triangle here. We have a 90 degree there, 30 there, and we're given that this is 8. We need to find X and Y. Okay, because I see 30 there, 90 there, I know this is 60. We have a 30, 60, 90 triangle. Now, the labels are S for the short leg, 2S for the hypotenuse, and S squared root of 3 for the long leg. In this case, we're given what 2S is. We're given the hypotenuse. The hypotenuse is 8. We're going to divide by 2 to find out that S is 4. And now we know what X is. X is 4 because X is the short leg. And once you have the short leg, to find the long leg Y, you take that 4 and multiply by the square root of 3. And that is the long leg. And you're done. Okay, so again, don't overcomplicate these special right triangles. Okay. All right. There's a worksheet for this one, so please, get a hold of Mr. Chappell, myself, and I'll give you the worksheet. All right. Thanks for watching.